This is our LEGO Segway project.
The purpose of our project was to learn about common motor and sensor control applications through the use of MATLAB software and LEGO Mindstorms kit. The purpose was to apply these techniques to design a LEGO Segway.
A Segway is a two-wheeled device that balances the user as they travel to their destination.
At the beginning of the project, we focused on the research of common LEGO motors and sensors. We started with motors, concentrating on the characteristics such as power, speed, and synchronization. Next, we moved on to experimentation with the touch sensor. Programming this sensor involved observing readings of open and close. With this sensor, we were able to create a robot that avoided obstacles by turning in the direction of the activated sensor based on the returned values.
The emphasis of the next week was learning to use color and light sensors. A color sensor was used to identify different colors on a color wheel. The color sensor was found to be limited in that it couldn't identify the shade or tint of the color. To fix the problem, we used a color sensor as a light sensor. The light sensor gave information pertaining to the tint on a gradient scale, but readings were not precise enough. An actual light sensor could be used to break the gradient light into 1,000ths. To test the color sensor, we made a line-following robot that raced around the track, pivoting every few seconds to remain on the line. Both kinds of light sensors were tested and observed, but no formal experiment was conducted. The last sensor we tested was the ultrasonic sensor. It was used to identify approximate distances to objects. A real-world application involved the robot driving around a box without touching it.
Next, we began work on our Segway design. We went through two prototype designs, the first one involving the robot having a horizontal balance and standing straight upright. This design was proven ineffective due to it having too high of a center of mass. The next prototype design involved a robot having a vertical balance and standing with the brick parallel to the ground. This design led to our final design, in which we further lowered the center of mass of the robot. This design proved to be the most balanced with our programming.
We used MATLAB to program these designs. Our first program used a proportional controller. It involved the robot driving in the direction it was leaning. A single reading was created by averaging 8 initial readings. The observed reading was compared to the initial value of the robot. If the initial value was higher, it moved forward. If it was lower, it would move backwards. The problem was that the command and interpretation time was too slow, causing the robot's actions to be jerky. Direct motor commands were used to minimize this time. A PID controller was used to correct the motion error. It uses the derivative to fix the rotational error and an integral to reduce the total error. It made the robot accelerate and decelerate instead of using a constant speed, reducing the jerkiness, but the connection speed was still too slow.
Learning to use MATLAB to program common components of many robots was a significant part of the course. The course had many deadlines which required us to plan wisely. We learned time management and good scheduling skills. We then furthered our design knowledge by learning real ways to produce prototypes. We started with the mechanical, then programming, and then correcting any problem.
Unfortunately, a robot did not work as expected. This is because the hardware functioned too slowly and was not accurate enough. For us, the best idea was to use the lowest center of mass and a PID controller. Bloopers, 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 bloopers! And this is our LEGO Segway project. No, damn it, redo that!
Oh! Oh! Oh my God!